Welcome all to the analog lectures series. So in this session we are going to calculate once again voltage current for the voltage gain for the next circuit. So here observe the circuit carefully, try to collect the data. I will be solving one question here. So actually there are two questions. We have to calculate the value of voltage gain by considering the value of CE. After that second case we have to remove the value of CE from the circuit. Again we have to explore the value of voltage gain. So there are two questions. First, let us go with the case number 1. So if I am considering the effect of CE, as usual, how will you calculate the voltage gain? Anyway, in order to do the voltage gain, current gain, output impedance or input impedance, we have to do AC analysis. Next thing is, step number 1, while doing AC analysis, we have to deactivate all DC sources. So here, if you observe the circuit, how many DC sources are there? So let me remove it. Here I have one DC source. That's all. I think only one DC source is there. So directly I can connect it with the ground. Step number 2, we have to short circuit all capacitor. Since the value of capacitor is very large, ideally it will be assumed to be infinity. So if the value of capacitance will be approaching to infinity, then capacitive reactance will become 1 by J times of omega C. When capacitance is approaching to infinity, reactance will be approaching to 0. Reactance 0 means it will be behaving as a short circuit. So you can remove all the capacitor by short circuit. We can remove all the capacitor by short circuit. So here I am shorting the capacitor. Here also I am short circuiting the capacitor. Of course, input port also we have to short circuit the capacitor. Finish. That's all. So that is how we are doing AC analysis. After that, if you observe, when I am short circuiting the emitter circuit, across the emitter, when the capacitor will be short circuited, automatically, can you consider the effect of this RE now? No. Why, sir? Because the resistance offered by the short circuited line will be 0. Whereas this is RE, since both are connected in parallel. So 0 into RE, equivalent resistance, 0 into RE plus 0 plus RE, that is the equivalent resistance of parallel circuit, that will be 0. So the finalized conclusion is emitter resistance will be gone from the circuit. That's all. So completely this entire circuit will be simply can be draw as, sir, it will be simply connected with the ground. See how simply our circuit came now. After that, see there, if I am taking this node is A, here I am having ground. Between A and ground I am having R1. Similarly, here also this is also ground. Between same A and ground we are also having R2. It means R1 and R2 both are going to be connected in parallel. And you also know how to draw the equivalent circuit for our transistor. So now it's time to redraw the circuit. So from this I will be starting from once again base, input impedance, that is supply voltage, and then we are having two resistor R1 and R2, both will be connected in parallel. So directly I am writing R2 and R1 are in parallel. After that we are entering into base terminal. See there, after that we are entering into base terminal. You know how to replace the transistor by its equivalent AC, right? You know how to do that. So let me do that from here. As usual, I am going with the RE model only, beta times of RE. After that, here I am leaving emitter terminal. So in collector terminal, we have to connect one current source, and the value of current source is beta times of IB. Now it's time to keep our attention with the collector and the emitter terminals. Emitter terminal is already connected with the ground, so directly I can extend the emitter line and connect it with the ground. If I will keep your attention with the ground, collector terminal, see there, between collector terminal means, so here we are observing the voltage. So voltage observing point will be always plus, opposite point will be grounded. So this will be ground. So between this terminal, between collector terminal and ground, we are measuring output voltage V0. Between same collector terminal and ground, we are having RC. So what is the conclusion? RC will be appearing across V0 only. So here I can connect the value of RC like this, and we know current flowing through the RC will be considered as IC. That current will be going like this. So this is the point where we are measuring the value of output voltage V0. So here we are going to measure the value of base current IB. Everything is over. Now it's time to solve the circuit. See there, since we are having supply voltage here Vn, same voltage, see same positive plate will appear here, negative plate will appear here, same input voltage appearing here also. Why? Because both resistors are, both circuits are connected in parallel. See, common point is ground for them. You can just join them together. We can just join them together and we can draw the common ground also. So this will become like this. So now clearly observe, both are in parallel. Yes sir. After that, see there, current entering point plus leaving point is minus, and the voltage drop can be written as base current into beta times of Re. Finish. Okay sir. Now it's time to bring the relation between input voltage and output voltage. See, all the values we know already. The output resistor, here we are having Rc, and did they given any base resistance? No, not given, right? So Rc, that's all. Collector current is given. Let's try to explore the value of answer for this question. How will you do that? Sir, the value of output voltage directly written as V0 is equal to minus Ic into Rc. Can I write like this? Am I right? See there, the voltage drop across this resistor is current Ic into Rc. But fortunately, the current is going in the upward direction. So current entering point will be plus, leaving point is minus for the resistor. Whereas according to the voltage polarity, the polarities offered by the current and the voltage polarities are opposite to each other. So I can treat this one as your equation number 1. Now if you observe the second equation, input loop, apply KVL here. If I am applying KVL, what I will be getting? Minus input voltage, that is the voltage drop across the resistor. Then here starting polarity will be plus, voltage drop can be written as base current Ib into beta times of Re. This will be equal to 0. From this, I can say the value of input voltage Vin is equal to base current Ib into beta times of Re. Treat this one as your equation number 2. Now it's time to bring the answer. So from this, we have to take the relation between output voltage and input voltage. If I will be taking the relation between these two, such that we will be getting the gain. Output voltage, what we got? The value of output voltage is simply minus Ic into Rc. Minus Ic into Rc upon input voltage. It can be written as Ib into beta into Re. Can we further written like this? See there, we all know collector current Ic can be written as beta times of base current Ib. So this base into Ib and collector current Ic will get cancelled directly. Finally, it will be Rc divided by Re. Now let us substitute all the values here. Go back to the question. We know how to calculate the value of Re from the question. See, to calculate the value of Re, what is the formula? Re is equal to thermal voltage upon collector current or emitter current. Since the value of collector current is given, directly you can substitute that value because both are approximately equal only. This will be 26 milli. Milli means 10 power minus 3 upon the value of collector current, that will be 1.3 milli. Milli means 10 power minus 3. Will get cancelled each other. 1.3. How can I say 20 times of 1.3 will be 26? See, if I am cancelling it, 20 times of 1.3 will give you 2.6. So the correct answer is 20 ohm. The value of Re become 20. Go back to this equation now. What is the value of Rc? Rc equal to 2000 ohm. So now substitute all the values here. Minus, it will be 2000 upon that value is 20. Yes or no? So 0 0 will get cancelled, 2 2 will get cancelled. Finally this will be equal to minus 100. Successfully we got the voltage gain according to the first case. First case is what? Voltage gain with the effect of common capacitor, emitter capacitance. Now suppose if there will be no emitter capacitors, it means if there will be no emitter capacitor, then that emitter resistance will exist. At the starting of the lecture, I told you that across the circuit we are having one emitter resistor Re, right? So that Re will exist because the capacitor Ce is not there. When the value of Ce is not there, then there will be no point of what I can say bypassing. So basically this is called bypass capacitor. Common collector emitter capacitor is called bypass capacitor. So that capacitor effect will not be there. So you have to consider the value of Re. Can you do me a favor? By considering the value of Re, take the same circuit just to bring the relation between input and output voltage. Try to calculate the voltage gain because we are repeating the same procedure again and again. Now you have to repeat the same procedure, but here in place of the short circuit you will be having one resistor. These kind of questions already we have been solved. So you can try to bring the answer and drop your answer in the comment section. Okay, this is all for this lecture. Remaining things we will see in the next class. Thank you all.